You love. I don't know. Just want this one.
Members, welcome back.
Yes.
So I was still teaching you what the direction of force is. The direction of force acts in this direction. So you can see this arrow pointing up. So it means that the force is
Upthrust force.
acting upwards. And if the force is
upwards,
acting upwards, and if the force is acting horizontally, so it means that the force is acting in this horizontal direction. So the magnitude of force, you can see that the arrow, when it is pointing up, shows that the force is acting upwards. Now you should know that force is indicated or is showed using arrows.
Yes, please.
That's why I drew a straight line here, and I showed you that the force is acting in that direction. Now we have this picture which is here. It takes a larger force for us to launch a space
rocket.
Yes, a space rocket.
A spaceship.
So I want you to think of something else that needs a lot of energy for it to move or to apply a force on it and to change its position. Think of something. I'm giving you only 15 seconds. Then I'm going to ask you.
An aeroplane. My answer. An aircraft.
Oh, shoot. Oh, a rocket. Yeah. Yay.
Bezos. National Geographic YouTube. Rockets. Jeff Bezos. The richest man in the whole world.
Members, I'm back. So you tell me, what are those kind of scenarios where you need a lot of force? Apart from the space rocket, we are going to say space rocket here when it's going up. Yes, Phyllis? Yes, Phyllis? Well, let us first watch this and then afterwards we can have more examples. So let me put it at normal, and then we'll see what is going on. Good. So there, when you are seeing, for there, let me stop there. Now, remember, when a rocket is going up, it needs a lot of force for it to go up, isn't it? First of all, it is enormous. It is too big. It is very heavy. Are we together?
Yes.
Yes, it is very heavy. It is enormous. It is too big.
Yes.
It carries a lot of heavy things. So it needs to go to space. And that means that it will need a lot of force. So you can see that the force it is taking, the direction that is taking is upwards. So that its direction will always be upwards because it is going into space. We know where space is. Space is up, space is not down, isn't it? Space is up, it's not down. So such objects, if the object is going up, so expect that the force that will be applied to that object will also face where? Upwards. Now, the force that is needed will depend on how heavy something is, how big something is, or how big the resistive forces are there. So in this space that we are seeing, there is a lot of resistive forces. Do you know the reason why when you jump, you cannot go into space? You just come back down. Do you know the reason why?
No.
Phyllis,
Gravitational.
have you ever tried to jump?
Yes.
Do you go to space after jumping?
No.
You just come back down.
Due to gravitational force.
Due to gravitational
Yes.
force, correct. So that is going to take us to a chapter where we're going to look at the types of forces. Now, the 15 seconds I gave you, Pav, welcome back. So you missed a lot, but we are showing you how this kind of rocket needs a lot of force for it to go up. And because it is enormous, because it has a bigger mass, because there is gravitational force, so it needs a lot of force for it to go upwards. And also the directional force will point where? Upwards. So that's what they were showing here. All right. Now that takes us to the types of forces. Types of forces. Correct. Types of forces. The types of forces. So let us look at the types of forces. Okay, someone has the answer straight away. Types of forces. Okay, now members, I'm going to ask you something. Are we together?
Yes.
I'm going to ask you something. But before I ask you, previously I gave you 15 seconds last time, and you'll be able to tell me what other kind of objects need a lot of forces for them to be moved. So now let us look at the types of forces. Now I'm going to ask you something. You have a table there. You have a table in front of you, or you are seated next to that table, and you have your books right there, isn't it?
Yes.
Now I want you, are you seeing those books which are on that table?
Yes.
Do you think there are some forces acting on them?
Yes.
Yes.
What are those forces? Show of hands.
Contact forces.
I want you to put up your hand and I see. Okay, Austin first.
You take to mommy.
Austin first.
Contact forces.
We have contact forces. Okay. Okay.
Yes.
We have what
Yes.
we call contact forces. Okay. We shall put here. I'll put it here and I'll say contact forces.
Contact forces.
What else? Yes, Ruth.
Non-contact.
I don't need Colin's answers, members. Ruth.
Sean, hello.
Non-contact.
Non-contact forces.
Contact forces. So, do you know the reason why I've not written this here under types? Do you know the reason?
No.
Because these are categories. These are categories.
Yeah. Categories of forces. I get.
You get it. Categories of forces. So those are categories of forces, but they are types of forces. Now, let me ask you, when you place the book right there, which forces are acting on that book? Ruth, you are putting up your hand.
Gravity.
Contact force.
Contact forces and non-contact forces are not types of forces. They are categories of forces. Are we together?
Gravity.
So we have gravitational force. We have gravitational force. What else?
Electrostatic.
Yes, Austin. I want hands. Austin.
Electrostatic force.
Is electrostatic force acting on that book?
No.
I want the forces acting
magnetic
on that.
Force.
Is magnetic force acting on that book? I want the forces which are acting on that book right now. Yes, Rosemary.
Friction force.
Friction force. Yeah, friction force. Okay. Because the table is your table rough or smooth? Is it rough or smooth?
Smooth.
It is very smooth. Okay, there is some friction force. Friction force.
Yes.
Which other forces are acting on that book? Yes. Which other forces are acting on that book? Because we shall see what gravity is. Pav, you tell us which force is acting on that book that you're having there.
Static force, is it the
static force? Oh, not really. Okay. Static force, not really. So let me show you something here. Force. Okay. Let's show you something. Yeah, where is it? Come on. I think I've just. Okay, let's see this.
On a drone.
Not Jumia, members, not Jumia, but about this. I want there, just there. Members, suppose that is the book. Are we together now? This time they have a ball. So if there is gravitation force, like how Phyllis told us that there is gravitation force, and gravitation force is acting where? Yeah?
Down,
isn't it? So if there is only one force which is acting down on an object, suppose I place this phone here. Suppose I place my phone there. If there is gravitation force on the phone and there's no any other force that is acting upwards, what will happen to the phone? What will happen to the phone if there is only gravitational force and there's no any force acting upwards? What will happen?
It will likely stay in the same place.
It will stay in the same place, but it will also sink into the table. Members, are we together?
How
It
come?
means because if there is no any other force that is acting upwards, the phone is likely to sink into the table. But because whenever you place something onto the table, there are two forces that are acting. There are two forces that are acting. There are two forces.
Acting.
So there is gravitational force
Acting.
acting downwards. There is also what we
And
call
then
the normal reaction
normal
force.
force.
Normal
Normal
force, or
reaction
we call
force.
it the normal reaction force.
Force.
So when you place the book there, there is the normal reaction force acting upwards, and there is also a gravitational force acting where? Downwards.
Downwards.
Such that those two forces are equal and the object can stay on top of that table without going up or without going where? Down. So it
Down.
remains on top. So the other force that we have seen is called the normal
reaction force.
Normal reaction force. Normal reaction force. The normal reaction force. Okay, so that's what I wanted to show you, the normal reaction force. So let us go back to our notes here. So which other forces do you know apart from those three? Now this
electrostatic force.
Okay, so we have the electrostatic force. We have the electrostatic force. Electrostatic. What else?
Magnetic.
Good, very good. Magnetic force.
Tension.
Thrust force.
Tension
force.
Tension force. Very many.
Upthrust force.
Upthrust force. Those are some of the forces that we know. Those are some of the forces that we know.
That
But I
we-
should
we
add
know.
on some that you know. There is what we call the adhesion.
Adhesion force and cohesion force.
Cohesion what? Cohesion. I hope you are writing
Force.
members.
Yes.
Cohesion force. So these are the types of forces, whereas these ones are categories of forces, are the categories of forces. Good. Now what we are going to do is that we are going to categorize these forces. We are going to categorize these forces, and we are going to have a table, and that table shall have the contact force and the non-contact forces. But before we categorize them, let us look at what are contact forces and
Categories.
what are non-contact forces. So categories of forces, categories of forces, categories. Yes, Ruth. Ruth, you are putting up your hand.
Contact force is one that acts at the point of contact between two objects.
Very good. Is the force that applies? Contact force is one that acts
At the point of contact between two objects.
Is one. Very good. Very good. Thank you very much. Is one that acts. Did you read it from the notes?
I had the notes.
Okay. Thank you for revising. Is one that acts at the point of contact. Point of contact between two objects. So that is the contact force. So there are examples which are there. They're saying that examples of contact forces include pushing. So there must be something in contact. For example, pushing, you can see this this lady here is trying to push this stroll, the baby trolley or trolley, so that the baby can enjoy being as in moved from one point to another. So she's pushing that trolley, or pushing objects with different parts of your body. Huh? Members?
Yes.
Pulling objects with different parts of your body. For example, you can pull something, you can pull a table that is in contact. So you must be in contact. Your hands must be in contact with that table so that you can pull that table. We have also what we call friction. Friction is also one of the contact forces, because friction is always, members, do you know what friction is?
Yes.
Hey, what's friction?
Friction.
Hey, who's defining? Yes, Ruth. Ruth again.
Friction is a contact force between one object moving over another.
Is the force between two objects that are in contact with each other. Yes, they are in contact with each other. All right. So with that, let me finish with someone.
Yes.
So Ruth, thank you very much. And I've just sent for you a switch for being very active in this class. Okay, now let us look at non-contact force. Okay, we can have your examples. For example, one, we have friction what? Friction force. Friction force. So friction force between two surfaces, that is an example. Another one is pushing or pulling objects with our bodies first of all. So let us look at Roman number 2, non-contact forces. This time I want a boy to give us the definition of non-contact forces. Non-contact forces.
Non-contact forces are forces.
Yes, Sean.
Non-contact forces are forces that are applied onto an object by another body that is not in contact with it.
Okay. So a force that is applied between two bodies that are not in contact with each other, isn't it?
With each other.
That are not in contact with each other. So a force applied to an object by another object which is in not contact with it, or a force that is applied to objects that are not contact to each other. So we can write what is in the book and say that is non-contact force, not forces. Non-contact force is a force applied to it's a force applied to an object by another that is not in contact, that is not in contact with Rosemary. Someone, you need to fix your microphone. I think it is Rosemary. Fix your microphone very well. It is giving us a funny background. Rosemary. Okay, thank you. Now, those are the categories of forces: contact and non-contact forces. Contact and non-contact forces. We are going to look at all these forces. I'm so interested to see this part here where we have non-contact force. So let us go ahead and we categorize our forces. I hope you have finished writing that. So let us go and we categorize our forces. So those were our forces. So we are going to draw our table and we categorize the forces. So this side we shall put contact what? Contact forces. And this side we shall put non forces. Who is there tearing, scrapping papers? Okay, let us proceed. So let us look at these forces. I ask one by one. Is gravitation force under contact or non-contact? You put up your hand. I'm down to, let me ask. Have first.
Gravity is a non-contact force.
Correct. Gravity is non-contact force. Gravitational force. Gravitational force. Okay, we have only 10 minutes left. We go to friction. Phyllis, friction. Where does friction fall?
Contact force.
Correct. So here we have friction force. Okay. We go to normal reaction. Where does normal reaction fall? We go to Sean.
Yes.
Where does normal reaction fall?
Contact force.
Correct. Normal reaction. We go to the next one, electrostatic force. I'm asking Ruth.
Forces,
Ruth.
forces.
Who's this one whispering the answer?
Forces and contact.
Ruth, where does electrostatic force fall?
Non-contact force.
Correct. Non-contact force. Sorry, should not. So this should be what? Electrostatic what? Electrostatic, isn't it? Electrostatic force. Okay, force under non-contact force. Magnetic force, that is Rovisa. Magnetic force?
Non-contact force.
Yes, correct. Magnetic force is non-contact. Good. We go to Austin. Austin, tension, where does it fall? No, magnetic force, where does it, sorry, tension, where does it fall? Austin. Austin, where does tension fall? Austin, come on. Austin. Okay, Austin has gone for breakfast. Let me ask again, Pav, where does tension fall?
Non-contact.
Okay, what is tension?
Tension.
What is tension, first of all?
Tension. Yes.
What is tension?
Non-contact, yes.
Now, do you know that when you pull something, let me show here a picture somewhere here. Where is it? Where is it? Here. Do you see this? Do you see this gentleman pulling a rope? Do you see them?
Yes.
So the force that is inside this rope is what we call the tension. Are we together?
Yes.
And the force to be in that rope, there must be someone touching that rope and pulling it. Or there must be something touching that rope and pulling it. Are we together?
Yes.
So it means that tension force, for it to occur, there must be two objects that are in contact. Are we together? Members, are we together?
Yes, teacher.
Yes, there must be two forces that are in contact, two forces that are in contact. So you can attach a rope to a box and then you pull the rope. So it means that you have touched the rope. So you are in contact with the rope. So the force that you are applying in the rope is what we call the tension force. So tension force, where does it fall now?
Contact force.
Yes, correct. Force in
Force.
contact force. We have tension force. And what
Contact.
else? What else? What else? We go to upthrust. Where does it fall?
Non-contact.
Upthrust. Okay, non-contact. Non-contact. Upthrust. Upthrust. How about adhesion
Yes.
force? Adhesion force.
Contact.
Contact. It must be under contact. Did you see me because I put my pen next to contact?
No.
No.
Oh, sorry, this is adhesion. I don't know. I like writing contact. Adhesion and also cohesion falls also under what? Contact forces. So that's how we have tried to categorize the forces. That's how we have tried to categorize the forces. All right, now I think we can call it a day, members. But I want to show you this example of non-contact forces, which is the gravitational force on YouTube, and I show you how the planets move without being in contact with each other. So they move because they are in the solar system. They're in the solar system. The one with the baby, please make her. Let me see which one. I think this one. This one is okay. This is an advert, but let us go to what we want. So you should know that the solar system is made up of planets, and these planets move in different orbits or in different paths of rotation. So we have the sun. The sun is always at the middle, is in the middle and followed with other planets. So the sun is at one position, and there are planets that are around it that are moving around it. And these planets that you are seeing them, they are not in contact with the sun. Are they in contact with the sun?
No.
They are not in contact, but they keep on moving around the sun. So it means that the sun has got a gravitational pull of these planets. Otherwise, this planet can move to this direction. This one here can move in this direction. This one can move in this direction. So the sun has a gravitation that makes them to move around it. So the force in between the sun and those planets is a gravitational force. Even here on Earth, we have gravitational force. If you throw something up, it will have to come down, meaning that there is a force that is pulling it to come. Are we together? Are we together? Yes. So that's how planets keep on moving. And those circles that you are seeing there, these circles are what we call the orbits. The orbits, the path through which the sun moves. So I'll stop there the video, and you can go to YouTube and put in solar system. You'll be able to watch this video. Everything.
Okay.
So are there any questions?
No.
No.
You don't have questions?
No
Have you
questions, no
understood-
questions.
Have you understood what force
Very
is?
well.
The SI unit of
Very well,
force,
sir.
the contact forces.
Yes.
All right. So
Yes.
thank you very much for attending the lesson, and
Yo,
I wish you
it's
the
our
best.
pleasure.
Yes. Next time
You too.
next time you tune in, and we shall have other types of forces. We shall start with weight, and we shall look at weight. Are we together? Okay.
Okay.
Have a lovely day, and bye-bye.
You too.
Excuse me, teacher.
Yes.
How can we get the previous notes?
The previous notes or the previous video?
Both.
Okay, the notes, the notes, let me cancel this. The notes, you go to the website here, you go to this website. So you go to the website, go to resources. Are you seeing resources?
Yes.
Yeah, go to resources and click on notes. So you look for the physics book. You come
To which
here.
website?
You go to the website
So I
that you are
have it.
using. Senchi's to e-learning.
Mm.
So you put in
Yes.
physics. You just put in physics is enough. And then you search for it, then it will bring for you that physics. Are you seeing it? Senior 1 physics textbook learner's guide. Are you seeing it?
Yes, I have
Then you
it.
click on this
Can see.
button